Hello, this is Susan Poss. I'm working in Chapter 4 on graphing. This is the last section in Chapter 4. It talks about words, definitions of relation, function, domain, range, vertical line test. So there's a lot of information here that will lead you directly into a college algebra class if you are headed in that route. So let me begin with these definitions. The first word that you see here on screen is called a relation. A relation is a set of ordered pairs. So it's a very broad definition. And when we look at the graphs in a minute, you will see what relations look like when you graph them. Second important word is the domain. So as we're looking at this set of ordered pairs that forms the relation, the domain will consist of all the x values, all the x coordinates of the points on the graph. The range will consist of all the y values, so it will consist of all the y values of the points that are on the graph. And I have some really simple examples here just to illustrate these definitions for you. In the first one, you see, maybe it would help if I numbered them. This is number 1. You see a set of 3 points. You'll notice the braces here to identify that this is a set. And then within this set, we have 3 ordered pairs. Okay, so that is a relation. It is a set of ordered pairs. So what belongs in the domain? Well, if you look at the x values, you'll see that the x values are 3, 1, and -2. So that's what's in the domain. The range consists of -6, 4, and -2. And those are the values that are the y values of the points that are in this relation. So here's another example. It's a set that has 3 ordered pairs, so that is a relation. The domain consists of the x values. Notice I'm separating those with a comma. And look at the range. All of the y values are a consistent same value. We talked about what that looks like when you graph it, so let me give you a quick sketch of what these points would look like. So there's 0, -2, and here's 1, -2. And here's 5, somewhere out here, -2. So you see that all of those points fall along a horizontal line. That's why we only have one value in the range. And looking at this last example, we have a set of 1, 2, 3, 4 ordered pairs. So that is a relation. You'll notice that there is a single value for the domain, and there are multiple values, 4 values in the range. A little bit later I'll be defining, in fact right now I'm ready to define a relation that fits a finer definition, a more concise definition, which is called a function, and that last one there would not be considered a function that we looked at. All right, so identifying functions. This is your next word to learn. A relation, remember a relation is a set of ordered pairs. So a function is a relation, but it's got this finer restriction on it so that for each x value, there is assigned one and only y value. So I've done a little Venn diagram. I don't know if you're familiar with that word or not. It's from a German mathematician, a Venn diagram, and you can see that I've drawn a large circle for the relations, and within that larger circle is a smaller subset, which we are going to call functions. And these functions will fit that finer definition that for each x value there is one and only one y value. Let me scroll back up and look at that last one we were talking about. So the reason this one is not a function is that for this x value 5, there are multiple y values assigned. So that would not fit the definition. It would be a relation, but it would not be a function. All right, so going further, all functions are relations. You can see that in the Venn diagram. but not all relations are functions. So you can see over there in my circle, I might have some things out here that fit the definition of relation, but they don't fit the definition of a function. So here are a couple of examples for us to try. We're supposed to decide whether this relation, this set of ordered pairs, also fits the definition of a function. So we're looking to see for each x, is there one and only one y assigned? And when I look at this one, let's see, to 11, is there another 11 in there with a different number assigned? No. Is there I'm looking at the -1, there's a -2 assigned. Is there another -1 that has a different number assigned? And so as I sift through that, I decide that yes, this is a function because to each x, one and only one y is assigned. And this will become clearer as we look at this last example here. Here's another relation. It's a set of ordered pairs, 3 ordered pairs. But look at this, to this 1, there is a 2 assigned, and then over here in this third ordered pair, to that same value 1, there is a 4 assigned. So this is not a function. It is a relation, but it is not a function. So that's one way to determine if something is or is not a function, is to look at the points, the ordered pairs. Sometimes you can't do that because you've got so many points, millions and infinitely many points. So there's a way to look at the graph and make that determination. There's something called the vertical line test. And I'll show you as I work these what that's doing. We're going to sketch several vertical lines through the graphs that you see below, these blue pictures. If the vertical line crosses the graph only once, that means that that relation is a function, because that would mean to that vertical x line there is only one y value assigned. So let me sketch in on this first one some vertical lines and take a look. That only touched the graph once. Let me put another one over here. That only touched the graph once. I'll put another one out here somewhere. That only touched the graph once. So I would say, yes, this one is a function. Because I can see if I put in multiple vertical lines, that's going to happen. This next one is a parabola. So let me put in some vertical lines here. That touches the graph once. This touches once. So this vertical line, which is an x value, let's say that one, if I gave you the equation for that, that would be x equals 3. Every single point on that line would have an x value of 3. And notice that there is only one y value assigned every time I draw that vertical line. So yes, this is also a function. Here's a horizontal line, and I think you can see that one pretty quickly. No matter where I put these vertical lines, running my vertical line test, it's only crossing this graph once. So the first 3 relations are functions. This last one is an ellipse. And right there, as soon as I run that vertical line, I'm touching the graph twice. Now right here, I could argue that I only touch it once. But if at any point along the way you can put in a vertical line and it touches the graph more than once, then you would say this is not a function. It is a relation. All right, here are a couple more for you. This one, excuse me, this is a vertical line. The equation for this vertical line is x equals -3. And if I run a vertical line through the vertical line, I am touching millions and billions of points assigned to x. So there's to this -3 here is assigned a 6. To this -3 here is assigned a 2. To this -3 here is assigned a -5. So this is not a function, because to each x there are multiple y's assigned. And this last one, as I run vertical lines here, this looks good to me. I don't think I can put in a vertical line anywhere on this that's going to touch this picture more than once. So I'm going to say yes, this one is a function. All right, so that's a good place to stop for a minute with our definitions and our use of the vertical line test to determine if something is or is not a function.